Welcome back to AT Math. Today, 1-4, Powers and Exponents. A power is an expression with an exponent and a base. Allow me to explain. The base is the bottom number here, which is a 5. Exponent is the little number in the corner. In this case, it's a 2. What happens is the base is the number we start with. So they're saying the base is 5, meaning that we have a 5. And the exponent tells us how many times to go multiply itself. So it's going to say, well, hey 5, I want you to multiply 2 5s together. Okay, so you get 5 squared, or 5 times 5, which makes 25. Or 4 to the third power means you start with a 4, and there's 3 of them. So 4 times 4 times 4, which makes 64. Now, a 2D figure, two-dimensional, with equal length and width can be called squared. In other words, there's 4 dots going this way, 4 dots going this way, and basically there's 16 dots total, meaning that it's a square because there's 4 across, 4 up and down. Because they're the same on each side, it's called squared. That's where you get 4 squared, meaning 2 4s, or 4 times 4. Now you try taking the 8-dimensional object, the 2-dimensional object with 8 by 8. Go ahead and take 8 times 8 to figure out how many dots there are. I don't even think you have to pause for this one. I think you can clearly see that there's 64 because you know that 8 squared is 8 times 8, which makes 64. Now a 3D equation is called cubed, so 5 by 5 by 5. Think of it this way, it's 3-dimensional because there's a length, width, and a height. Or if you go back here to the little dots, there's only length and width. Or length and height, how you want to look at it. Since there are 3 dimensions, you're going to have 5 to the third power, 5 times 5 times 5, which makes 125. And in this case, you would have feet, so it would be feet cubed. Now you try to take a Rubik's Cube. Let's say each little space was an inch. We'll say it's a larger Rubik's Cube. If each little block measures an inch, what is the volume of a Rubik's Cube? Hint with this, that an inch each means 3 inches. It's going to be 3 inches by 3 inches by 3 inches. So go ahead, give it a guess. Doesn't have it, but the answer to the you try is going to be 3 cubed, which is 3 times 3 times 3, which you'll find is 27. And I hope you got that right. Next page. Some vocab. So if you have something to the second power, it means square. So 4 square, 4 to the second power means 4 squared. A 3 in the corner means the third power, or cubed. These are the only 2 types that have a special name. 2 is squared, 3 is cubed. Everything after that is to the 4th power, 5th power, 6th power. So if you have a number in the corner, and it's more than 2 or 3, it's just to the 4th power, 5th power, 6th power, etc. If it's 2, you can say 4 to the second power, or you can just say 4 squared. Or here you can say 6 to the third power, or just 6 cubed. By the way, I didn't include this, but what happens if you have just a 1 in the corner? Well, anything to the first power is itself, so it would just make 4 anyway. So that's why they don't include that. Now, if you have -5 squared, because -5 is on the inside of the parentheses, it means you're going to take an actual -5 times another -5, as you can see here. 2 negatives make a positive, so the answer is going to be positive 25. However, if the square comes here without parentheses, so it says the square comes before the negative. In other words, if you have it, even though it looks like -5 squared, just like this one, the negative and the exponent are both competing for that 5. Understand that 5 is actually linked to the square. So 5 squared is attached. It's one value. So you have to take 5 times 5 first. Then the negative gets to take a turn. So you have to take 5 times 5, which makes 25, and the negative waits and turns into a negative. You have to do the multiply first. So in a case where you have an exponent or a negative, the exponent goes first, part of the order of operations. So you try. Go ahead and pause me this time. Go ahead and pause. Let's see how you did. So you have 4 cubed that has to come first. 4 times 4 times 4 is going to be 64. The negative waits to make it -64. Here, the -2 is on the inside, so it's -2 times -2, which makes positive 4. Here, -3 times -3 times -3 is going to make -27. And here, even though the negative's there, 2 to the 4th power comes first, which makes 16. The negative waits to make it -16. And did you get all 4 right? Now, take this here. 2 to the 5th power, 2/5, 2/5 squared. Really, it means you have 2/5 times another 2/5. So it's important to have a parentheses if the entire fraction is to a power. So the entire fraction squared. In other words, if you're going to take 2/5 squared, you need to have the parentheses. Don't have this, because that changes the equation. Because that's 2 squared over 5, which makes 4/5. So we got to know which way to go here. So 2/5 times 2/5, top times top, bottom times bottom. 2 times 2 is 4, 5 times 5 is 25. And I just showed you if you didn't have the parentheses, you would have 2 squared over 5, which makes a different answer. Why? Because the 5 is not being squared in this situation. Why isn't it being squared? Because this is sitting on top, so it's servicing the numerator, not both. You try, go ahead. I'll pause me, go ahead. Let's see how you did. Well, a little more legwork on this one. 4/7 to the 3rd power. You got 4/7 times 4/7 times 4/7. Ooh, that's a terrible looking 4. 4 times 4 times 4 is 64. And 7 times 7 is 49. Times 7 is 343. Now, if you're asking yourself, can we divide this down and find the greatest common factor? Just ask this. Can we divide any 4s by any 7s? No, so you can't do anything with them. So 64 over 343 is your answer. Here, -6/8 squared. Before we do anything else, I'm going to go ahead, and because you're doing it inside the parenthesis, you can divide by 2 first. In other words, I can divide both of these by 2 and get 3 over 4. So I'm going to get -3 over 4 squared, and you get 9 over 16. Very nice. Now, this one's a little weird, a little more difficult. It says 64 is the answer and the base is 4. Here's all it means. It's basically asking you how many times do I have to multiply 4 to get 64. Well, it means this basically. It means 4 to the x equals 64. I'm going to give you the easy version of this because it's really easy to overcomplicate. Just make a line of 4s and just start taking 4 times 4 times 4 in your calculator until you find 64. So 4 times 4 makes 16, times another 4 is 64. So basically, if 64 is my answer and my base is 4, my exponent I need is 3. And that's all you have to do. So 4 to the 3rd power. They're probably just going to ask you for the 3. If you write 4 to the 3rd power, that's perfectly fine. Covers all bases. I got no problem with that. Now you try, go ahead, do the same method. Hint, once again, you don't want to take 2 times 2 times 2 times 2 times 2 and count them up till you get to 128. Multiplying, of course. Go ahead this time. Pause me, go ahead. Alright, let's see how you did. So let's go ahead and take a bunch of 2's, see where it leads us. Again, I'm going to go ahead and, work it out like we're doing this together here and not just me having the answer. 2 times 2 is 4, 8, 16, 32, 64, 128. Lucky guess. So 2 to the 7th power. And then 3 is for 27. Let's see. 3, 3, 3, 3. 3 times 3 is 9, times 3 is 27. So I just needed those. 3 to the 3rd power. 625 by 5s. 5 times 5 is 25. Times 5 is 125. Times 5 is 625. So I got 5 to the 4th. And now 4s. 4 times 4 is 16. Times 4 is 64. So I get 4 to the 3rd power. 7 times 7 is 49. Times 7 is 343. Times 7 is 2,401. So that's going to make 7 to the 4th power. And there you have that. They get tougher. If your answer is 16, your base is -2. It's the same idea, but we just start with -2's. So -2 times -2 is 4. Times -2 is -8. Times -2 is positive 16. Here's a hint. If there's an even number, it's going to be a positive answer. If it's an odd number negative, it's going to be a negative. So right away, since 16 is positive, it has to be a positive number of -2's. So you're going to be 2, 4, 6, or 8. It's got to be. So in this case, there's 4 of them. So negative 2, don't forget parenthesis to the 4th power. Notice there's a parenthesis there, so have that. Also, 1/8 with the base of a half. It looks kind of weird, I admit, but just line up the halves, and you'll see what I'm saying. The half times half is a 4th. Times another half is the 8th. So there's 1, 2, 3. Now you might say, that's an odd number. How does that work? Yeah, but we're not doing negatives. We're just doing fractions. And basically, when you're times by fractions, the number value gets smaller every time if the fraction is less than 1. So 3 halves make 1/8. So 1/2 parenthesis to the 3rd power. Go ahead, you try it this time. I'll pause me. Alright, let's see how you did. Base of negative 1/7. Answer was negative 1 3/43. No, there has to be an odd number of negative 1/7 because your answer is negative. Turns out there's 3 of them, so it's going to be negative 1/7 to the 3rd power. Here, negative half, and the answer is going to be negative 3 halves. Again, a negative base that keeps being a negative means there must be an odd number of exponents. Turns out it's negative 2, I believe, to the 5th power. Here, 1/4 times 1/4 times 1/4 times 1/4. How many fourths does it take to get to 256? I believe it's going to be 4 of them, because 4 times 4 is 16, times 4 is 64, times 4 is going to be 256. And finally, negative 3. How many times multiply negative 3 does it take to get to 81? Again, it's a positive outcome, so there must be an even number of negative 3's. Negative 3 times negative 3 is positive 9. Times negative 3 is negative 27. Times negative 3 is going to be positive 81. So negative 3 to the 4th power. Now again, you can't read the word problem in this case because, or unless you have your textbook, which would be wonderful. If you don't, I'll put it right here. It basically says you have a bacteria, and it looks like it's doubling every hour. So I'm saying it starts with regular 1 bacteria, and in hour 1 it's going to double to 2. And hour 2 is going to double to 4, hour 3 is going to double from there, etc. And I don't remember what it was asking for, so let me just ask you, what would it be, let's say, in hour 5? So how would you figure that out? Well, if it's doubling every time, just take 2 to the 5th power. So go ahead and find that answer. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. I don't remember what the book was asking, so if you have it, please solve it. If not, we'll have to review it in class tomorrow. And here, now do page 29, 2 through 38. Again, we're going to hold off on that till class time for tonight. There should be a quiz down below. Take a look for it. Thank you again. Bye.